right, students, I am back. I'm going to try to get this video up and running. Now, I want to throw one idea out there. I forgot to mention in the previous video. We're talking about significant figures. The definition of a significant figure are all digits known to certainty and the first uncertain one. And this will help you do the one where they have actually measurements here on actual devices. So to give you an idea, if this is 13 and this is 12, and this is let's say this is a column of water, all right? And by definition, significant figures are all digits known to certainty and the first uncertain. I'll say that again, all digits known to certainty plus the first uncertain one. Well, here's what I know that is certain. 12. 12 is certain, all right? However, guess what? The next one right here is uncertain. So we'd say 12.4. You know, to be honest with you, 12.3 would be reasonable. 12.5. I messed that one up. Excuse me. 12.5 would be reasonable. All right, answers. Because guess what? Certain, uncertain. Certain, uncertain, certain, uncertain. All right. So if I have something that looks like this, let me make up another one. I need better erasers here. Let's suppose I have something that looks like this. Let's suppose this is 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is 9. And I want to know the reading right here. What do I know is certain? 8.1, 2, 3, 4. 8.4 is certain. If I want to know the reading, right in there. If I guesstimate 8.45, other ones you could say 8.46. Again, reasonable answer, but 8.45. But here, you're for sure this has to be 8.4 something. All right. So hopefully we got that. All right. So let's erase all that, and let's start afresh here. So I want you to get down this vectors. What is a vector? Well, vectors, let me just say this, vectors are going to be used throughout the rest of the year. All right? A vector quantity is basic. What we do on a vector quantity, we take and use arrows in the place of force or velocity or something like that. All right? So let me give you an example. If I say, let's suppose I am flying a jet. And by the way, vectors, let me just put it up here. Vector quantities require both magnitude, and direction. All right? Scalar quantities, scalars have magnitude only, and they don't have direction. All right? We're going to see that velocity, acceleration, force, all are vectors, so they require both magnitude and direction, all right? So here we go. Follow with me. So let's suppose and by the way, we have to define direction. If I have an arrow pointed here, this is, how do I write? You can't say northeast. If I am 30 degrees above that eastward component, all right? 30 degrees above that eastward component, you can't say northeast because northeast is 45 degrees, all right? So we say this is 30 degrees north of east, all right? North, south, east, west. Right here, this is 20 degrees. How would I define this? This is 20 degrees southward of our eastward component. All right? Well, let's just do this one. Let's say this is 80 degrees. Well, this is 80 degrees south of west. And if I have 45 degrees, you can say 45 degrees north of east. You could, I'm sorry, north of west. Or we can just say northwest. That's right at 45 degrees. Now, here's the alternate. Here's the alternate on this. Drop my markers, sorry about that. If this is 20 degrees south of east, do you know what this is? This is 70 degrees east of south. That's another alternative. Here, this is 60 degrees east of north. Northwest still. I don't want to say west north, that's weird. And 10 degrees west of south. Now keep in mind everything's in reference, if you remember standard math, everything's in reference to the x. So we usually, if you'll notice, the black is what is more preferable. So what I'm going to do is I'm going to make up some, all right? We're going to make up some, and I'm going to give you, I want you to pause it when I tell you to pause it, and I want you to, all right, pause it, and I'll put answers up here. So if I have this right here, this is 60 degrees. This right here is 20 degrees. This right here is 65 degrees. This right here is 40 degrees, okay? Now what I want you to do, pause, press pause. You're not pausing, all right? Pause. Thank you. All right. Now, I want you to write the solutions to these. Here we go. I'm just going to do the standard one. 60 degrees north of east. This is 40 degrees south of east. This is 65 degrees south of west. This is 20 degrees north of west. Hopefully you got those right, okay? So let's continue our thought processes on this, all right? Now that we know how to do vectors are arrows that gives you your magnitude. Now, the greater the magnitude, like a magnitude would be like Newton, forces in newtons, velocity is in meters per second, all right? And acceleration meters per second squared, we'll talk about that later. Let's do this way. Let's suppose, I'm going to do easy vector. Let's suppose I am flying a plane, or I'm just saying this, 50 meters per second, and I have a crosswind of 10 meters per second. Now, hang with me. I want to know what's called the resultant. Now, here's by definition. The resultant is when we combine all the vectors into a single vector. All right, it's the result. Or when we combine, add them all. Those are all synonymous. So what we're going to do is convert this to a single vector. Now, this is one of the easier ones because they're at 90-degree angles, all right? I'm just trying to make sure my video's doing okay here, all right? So 50 meters per second. Here's what you do on these. This is one of the easier ones. So if you think about it, if wind is going here and wind is going there, and I don't have a plane here, I used to have a plane. If I fly my plane, I want you to think about this. I can point the nose of my plane. Let's say this is my plane. If I point it toward the north, but I have a crosswind, you know what's going to happen? The result is going to be, even though my plane is facing north, it's going to take me eastward a little bit. And if you'll notice, this is a longer arrow for 50. This is a shorter arrow for 10. So here's what I'm going to do. Make a box. My resultant is going to be there, all right? So here's what I want to do. Since it's a square, we can do Pythagorean's theorem on this. So normally you'd be in class and you'd get the number for me. So what I'm going to do is 50 squared plus 10 squared. Whoop, let's see. Even I messed that up. 50 squared plus, no, my calculator's not going to do it. Let's try this again. 50 squared plus 10 squared equals, I get 2,600 doing Pythagorean's theorem. And then I'm going to square root that dude. And I'm going to go one place past the decimal. I get 51. Guess what? The plane is actually going to be going 51 meters per second. But now I need to find the angle. I need to find that angle, okay? So I want you to think about this. I'm going to have to put this to the side. Sine of theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent of theta is equal to opposite over adjacent. All right? Opposite over hypotenuse is sine, cosine, adjacent over hypotenuse, and tangent. All right, so give you a chance to write that down. All right, as you write that down, I'm going to turn this radio off. All right, so here's what I need to find. This side is actually 50 because it's a rectangle. We know this is 10. So here's what I'm going to do. I know opposite and I know adjacent. Tangent of theta is equal to 50 over 10. All right. So now when you need to go, like with me, I have to make sure that I am in degree mode. And I am. And I'm going to go to second, I'm going to do inverse tangent of 50 divided by 10. And when I get this, I get 78.7 degrees. All right. So watch this. 78.7 degrees. Now, this is my start point. What do we got here? All right. 78.7 degrees north of east. All right. Let's do another one. Let's do another one. Make sure you have that down. All right. So looking at the second one here, I'll just make it up. I'm just going to say we're applying a force. Oh, let me make that a little bit shorter. Whoop, drop that. Let's suppose this is 50 newtons. This is 40 newtons. I want to find the resultant. I want to find the resultant here, okay? So the resultant looks like this. That is the resultant, all right? Let me do this. I'll feel a little bit better. Let me make this in red, all right? Let me adjust that to red. Sorry about that. All right, this is what's given to you. Find the resultant. So since this is already at 90-degree angles, the due west, due east, due south, due north, whatever. So draw my triangle. If I'm pulling this way and pulling this way, the result is going to be pulling somewhere. Think about it as a rope. You got one person pulling this way, another person pulling this way. It's not going to be from here to here. If you put here to here, it's wrong. So what you're doing here is this. So this is my theta, all right? So what I want to find out is what's the length of that arrow? So we're going to do Pythagorean's theorem again, all right? So, 40 squared plus 50, I don't know why I'm doing that. Root it. So we get 40 squared plus 50 squared. I add them, I root them, I get 0.5. I get 64. This is 64 newtons. I'm almost there, all right? Let's use this angle in reference to the x-axis, all right? Guess what? We can actually use sine, cosine, or tangent. We could use any one of those, okay? So here's what's going to happen, all right? Let's see here. I like tangent better, so let's use this. Remember, this is 40 over here, because it's 40 here. So the tangent of theta is equal to opposite over adjacent. So I'm going to go on my calculator, make sure it's in degree mode. Second tan, yours is going to be a little bit different. 4 divided by 5. I get, watch this, 38.7 degrees. All right, so we know 64 newtons, 38.7 degrees. And where is this acting? Boom, boom, south of west. South of west, okay? All right. I'm going to put 2 on the board, and I'm going to let you work them on your own. And then I'm going to do a fast work. All right, so let me put 2 up on the board. Draw them out. If I say 20, 30, let's do meters per second. Meters per second. And the other one is 5 newtons due north, 3 newtons due east. Oh, let's do one more. Let's do one more. I'm excited here. Let's do one more. I got to make sure I got enough room here. Here's one. What if I had this? 6 newtons due north, 8 newtons due south. All right, we're going to start with that one. All right, so pause the camera. Please pause it right now. I'll give you 5 seconds to pause it. I want you to work on those on your own. All right? All right. Well, right now you should be back from your little break. Let's draw a picture. 6 newtons due north, so watch this. Draw a picture. 6 newtons there pushing upward. 8 newtons acting downward. Guys, think about this. And girls, when I say guys, I mean everybody. 8 acting down, 6 acting up. What's the resultant? If you're only pushing 6, but pushing 8 down, you get what? 2 newtons due south. That's your answer, okay? Hopefully you have answers for the next 2. Don't cheat off of me now. I already know how to do this. Now, I'm going to go back to red, and I'm going to go fast. Watch, 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 watch. All right. So draw, kaboom, kaboom. All right. And my theta, I'm going to use this theta. So here's what I'm going to do. The answer here, I'm going to go fast. So 20 squared plus 30 squared equals, and I'm going to root it. Here's my answer, 36.1. All right. And my angle, it's meters per second. Without your units, it's a half a point off, all right? I need to do my angle. My angle, tangent. Oh, now, this is 36.1. I'm going to use tangent. Tangent of theta is equal to, this is 20 over here, opposite over adjacent, so 20 over 30. So I do second tan. Let's see here. 2 divided by 3. I get an angle of 33.7 degrees. 33.7 degrees. So 33.7 degrees. And what is this? South of east. That's my solution. All right? You can pause and write this down because I'm moving on. Now, the next one, if you notice, I did not give you the picture. I gave you words. So what you're going to do is write it. The first thing you need to do is write it out. So, or draw the picture. So 5 newtons this way, and I gotta make it big enough for you, 3 newtons that way. All right, Newton is a unit of force. All right. So what we want to do is find the resultant here. So watch what I'm going to do. Kaboom. I have a 3, 5 something triangle. So here's what I want. Oh, we're going to find this angle too. I want to know magnitude and direction. Magnitude and direction. You have to have these for all of those, all right? So I'm going to do 3 squared plus 5 squared root 0.5. And what you get is 5, this is 5.8. So I get 5.8 newtons. Make sure I got the correct units right, okay? And if the last one, I don't remember what I did, make sure you have the right units. I may have done the wrong units on that one, but this one newtons. If the last one was meters per second, I don't remember. Make sure you have the correct units on there, okay? Let's see, let's do the angle. The opposite is 5. Tangent of theta is equal to 5 over 3. All right, so I'm going to do second tan of 5 divided by 3. And what I get, whoop, I did something wrong here. All right, I got to do it again here. Second tan, I hit the wrong button by accident. Second, inverse tangent, 5 divided by 3. Make sure it's in degree mode. I have 59 degrees. So I got 59.0 degrees. So 59 degrees north of east. All right. Now, with that information, I want you to see what I've got here. This is video 2. This is due, let me make sure I get the right one here. This is due day 2, all right? Now, if you'll see this paper, it says due day 2. But you know what I did? These are your practice problems. And you know what I was nice enough to give you? If you look closely, you can see I put the answers down there, all right? Now, if you didn't know this already, let's quickly review what's due when. All right, these 2 pages, this one and this one, are due day 1 when you see me. What is due day 2, you see me, is this one. And I put the answers there for you, all right? So the answers are listed there, so you will work that. It'll probably take you, if you grab a hold of this, it'll take you about 10 minutes to do, all right? Do you have, hopefully you nabbed that, and here's you can email me at michael.dollins@cchs165.com or mldollins@gmail.com. And if you have a question, I'll be glad to get back with you, okay? So the first video was over one set of information. Vectors you're going to deal with. The conversion we dealt with, you're going to deal with all this year. And if you take any future AP classes with me, you're going to have that for the next few years. This vector thing right here, you're going to have this for all this year. Vectors are a thing that you need to understand right now, okay? If you have any questions, you make sure you email me. If you email me, you may want to give me your phone number, and I can give you a call, all right? All right. And always remember, all right, physics is fun, all right? Take care.